Hi Aaron, today we're gonna solve the problem 104, maximum depth of binary tree. This is an easy problem, and let's read the description. Given the root of binary tree term is maximum depth. A binary tree's maximum depth is a number of nodes along the longest path from the root node down to the furthest leaf node. So apparently for the input, they're gonna give us a tree node root, and we're gonna find the maximum depth. So the first thing come to my mind is traverse solution. So apparently we're gonna first write a traverse function, and the return will be void, and the input will be root. And if the root is equal to none, we're gonna return, and else we're gonna start counting, and depth is equal to depth plus 1, and we're gonna count the maximum depth in the traversion process, and then traverse the root to the left, and then traverse the root to the right, and after that we need to make the depth is equal to depth minus 1, because we are not in that node anymore, we are leaving the node. And for the main function, it will be traverse root, and at the end we're gonna return the maximum depth. So this is the traversion solution. So what's the time complexity of this solution? So this one is big O of n, and n is the number of nodes in the binary tree, and this is because in this solution we exactly traverses each node once, and for the space complexity is big O of h, and h is the height of the binary tree. So this is because the maximum depth of the recursion stack is determined by the height of the binary tree. And in the worst case scenario, the binary tree is completely unbalanced, and the height of the tree is equal to the number of nodes, resulting in big O of n space complexity. However, in a balanced binary tree, the height is logarithmic with respect to the number of nodes, resulting in big O of log n space complexity. So it all depends on the situation, but overall the space complexity is gonna be big O of h. So there is another way to solve this problem, and we're gonna think whether a recursive function can be defined to derive the answer to the original problem from the answers to subproblems. So if that's possible, we're gonna write the definition of this recursive function and make full use of the return value of this function. So in this way, we can also consider write a recursive function, and the main problem gonna be subproblems, do some operations to do the subproblems. And the time complexity will be big O of n as well, since it traverses each node once, and the space complexity will also be big O of h, like we said before. And also they have the worst case, the h is equal to the number of nodes. And I think there is also one thing we need to notice is that in the binary tree, the input, the tree node represents a node in the binary tree, and the input representation, it looks a little bit misleading because it looks like an array, but it's actually a way to represent a binary tree using a level order traversal. So it's not an array, it's the input is indeed the binary tree, the binary tree node.